Alright, so if we look at problem number 47, it says what angle should the water gun be aimed at for the maximum range or the greatest horizontal range? Well, let's think about that. We said that the range is equal to the initial velocity squared times sine of 2 theta over g. Now I could rewrite that as the velocity, the initial velocity squared over g, which is a number. We'll get some numbers if we plug them in. That would be a number, times sine of 2 times theta. So the only thing that we really have an impact on is theta. So what we want to know is what value for theta will give us the maximum value for sine. So let's graph that. Sine of theta, just to kind of refresh ourselves of what sine of 2 theta would look like. And so what we're really looking at is what is the greatest value for sine of theta, right? Well, or I'm sorry, sine of 2 theta. So if I plug in sine of 2 times theta, but instead of theta I'll just write x for the calculator. I get this, and I'm going to zoom in. We'll go to trig zoom. And so as we look, we see that sine has a maximum value at about right here. Okay? And since we have our answers in degrees, well, we have one in radians, but let's make sure we're in degree mode on our calculator. We're not, so I'll go to degrees. Now I'm assuming that when I go to degree mode, I might need to change my window from, I don't know, 0 to 360 degrees, right, because that's in degrees. Now let's graph it. Alright, so it's a sinusoidal oscillating function. The maximum value occurs at about, well, let's go, we want positive 1. So what we're looking for is this y value, and it looks like it gets pretty darn close to 1. And if you guys remember, sine of theta is actually has a range of positive 1 to negative 1. Now when we put the 2 theta in here, the only thing that changes really truthfully is how we get to 90 degrees. Okay, so what does that mean? Well, let's just calculate the maximum value. So I'm a little bit to the left, a little bit to the right, somewhere in the middle. So it looks like 45 degrees y equals 1, right? Now what does that mean? Well, let's just double check. 45 degrees, yep, that's correct. What does that mean though? Well, what that means is my greatest value for y, in other words, or the range for sine of 2 theta goes from 1 to negative 1, right? And I could graph this another way too. I could write it on a number line, but the greatest y value goes from 1 to negative 1. And the greatest is 1. It'll never be greater than 1. Well, when does this occur? When theta is equal to 45 degrees. Right, based on the graph we just did. So when we have an angle of 45 degrees, we get 2 times 45 all over g, while sine of 2 times 45 is actually the same as sine of 90 degrees, which is actually this times 1. So the maximum range occurs when sine equals 45 degrees and we multiply it by 1. Now truthfully, I think in your textbook you could just memorize this, but I think your textbook and in your notes I gave you that. But this is where it comes from. I never really showed you guys where we derived it from.